Okay, hello everyone. So today we are going to do the compound interest. That's your exercise 6.5. And I hope you understand the simple interest. That was just the simple like the flat rate depreciation. So this one is a compound interest. This is like the reducing balance depreciation, but we are adding the interest instead of taking it away in the case of depreciation. So make sure you write the keywords and the definition and examples in your books. And as a warm-up, you make sure you watch the Edrolo videos. They are really good. Some of you were asking me about recording the detailed examples. So all the detailed examples are on Edrolo. So please watch them. And I have already added one column for Edrolo who I can see who is watching, who is not. So you can see that in the work checks. So make sure you're watching them. That's a part of your coursework as well. Okay, so compound interest. What is compound interest? Compound interest is calculated at the end of a certain time period, and the interest is added onto the principal, and then the interest for the next time period is calculated using this new amount. So you pay interest, and that interest gets added to your principal amount which you have borrowed, and then next year you will pay interest on all the amount together. We'll do one example, then it will make more sense. So okay, for example, consider the table below. The simple interest is here. So we are considering the same example for comparing. You have invested $3,000 at 5% per annum. PA is per annum per year for compound interest, compounding yearly every year to 5% per annum, and the simple interest after nth years as well. So the same conditions for simple interest and the same conditions for the compound interest. So let's see what happens in the compound interest and the simple interest. So it's a 5% per annum. So 5% is 5 over 100 times your invested amount, which is 3,000. That is your principal. So 5% of 3,000 is $150. So initial amount invested was $3,000. So now you got interest of $150. So that gets added. So you get a total of $3,150. So in the case of simple interest, we still do 5% of 3,000, which is $150. And then we add that. So you get $3,150. So after 1 year, it stays the same, whether it's compound or simple. What happens after that in the second year? So in the second year, you can see it's a 5% of not 3,000, but your last year total amount with interest, which was $3,150. So you can see the 5% of that, which is $157.50. Now you add this new interest to your last year's principal and interest, add that together, and you get a new amount. So you're not adding that to 3,000, you're adding that to $3,150. That's a difference. Whereas in the simple interest, you still do 5% of 3,000. You keep on adding that 150 every year to the last year amount. But you're not paying interest on interest. But in here, you're paying interest on your interest as well. So that keeps on going for next year. So that's the main difference. So you can see at the end of 4 years, you will get more interest in the case of compound as compared to the simple interest. So it's $46.52 more because you are adding that amount every year at the end of the year, and then you are doing 5% of that new amount every year. Okay, so that's one of the example. So the next thing we need to do, okay, so the compound interest recurrence relation and general rule. So you need to remember that. So recurrence relation is finding the next term. So whenever you're writing the recurrence relation, remember they are not, it's always for the next term or the next year or the next month. So the future value at the end of the nth compounding period, Vn of compound interest investment is given by the recurrence relation. So V0 is the starting value, the initial value, as if you look at the previous example. So 3000 would be our V0 because that's the starting value. And then the next year, n plus 1, the next year would be 1 plus r divided by 100 times Vn. So r is your rate of interest, and from here it would be 5%. So 1 plus 5 divided by 100 times your Vn. Vn is for the last year amount. So if you're calculating for the first year, then it would be 3000. So that's how you're calculating for next year. So that's your recurrence relation. And for the general rule is like a formula for finding the compound interest. So Vn equals 1 plus r divided by 100 raised to the power n. So n is the number of years, the time period, whether it's monthly or yearly, that's a time period. Times V0, V0 is a principal, the amount invested, that was 3000 in the previous example. So, and whatever interest you are earning every year, it is with the current year, take away the last year interest amount. So that's how you get it. So you need to remember the highlighted things over here. So make sure there are things highlighted all over the slide. So those are the important notes for you to put in your books. And also there are some worked examples in here from your textbook. So if you want, you can also put them in your summary books. All right, so that's a worked example from your book. Alan inherits $35,000 and decides to invest it in an account where he earns interest of 6% per annum compounded monthly. So now this is the important part, monthly. So you need to take care of that. If it's monthly, you need to change your interest every month, like to monthly. So you need to find the R, the percentage interest rate per compounding period. Then you need to write down the recurrence relation. Then you need to write down the general rule. And then you need to find the value of investment after 7 years. So let's start what is given to us. So we know the principal amount, V0, that is $35,000. And we know that he's earning interest of 6% per annum. So first of all, as I said, because in the example, it says monthly, compounded monthly. So there are 12 months in a year and 6% is for whole year. So you divide that by 12 to get that per month. So 6 divided by 12 is 0.5%. So 0.5 is your rate of interest. So you're not using 6 there, you will be using 0.5 for rate of interest for R. Okay. So now for writing down the recurrence relation, let's find out Vn. So that was your first part, that's done, like finding the annual rate of interest for compounding period. So it's monthly and you divide it by 12 and you get 0.5. The next was to write down the recurrence relation. So, you need V0, Vn for that. So let Vn be the value of an investment at the end of nth month. So V0 is your starting value, and your starting value is $35,000 from the question. And then Vn plus n plus 1, if you remember your recurrence relation in that slide over here, you can see the formula for recurrence relation. V0 is the starting value, which is $35,000. Then Vn plus 1 equals 1 plus r. So what is your r in this question? We already found that, 0.5. So 1 plus 0.5 divided by 100 times Vn. So Vn will be for your last year. So you just keep on doing that. So your recurrence relation becomes V0 equals $35,000. Then Vn plus 1 is 1 point, because if you solve that, 1 plus 0.5 over 100, it will give you 1.005 times Vn. So that is your recurrence relation. Remember, whenever you're writing a recurrence relation, you need to mention that V0, then n plus 1, and then like this. It's only the relation. They're not asking you to find anything. They're just asking you to write on the relation. So that is the relation here. Then the rule. The rule is a formula. So as you knew from that slide, so the formula is Vn equals 1 plus r over 100 raised to the power n times V0. So you do the same thing here, substitute the values, that's it. So 0.5 divided by 100, so that gives you 1.005 raised to the power n times V0, which is your initial value, $35,000. So this one is your rule. This one is a formula for finding compound interest. That's a recurrence relation. This is the formula. So now the last part was to find it after 7 years. So as you know, it was compounded monthly. So you need to times that by 12, because if it's for 7 years, 7 times 12, it's 84. So n is 84. Then you write your rule to find the investment. So your formula V84 would be, so n is the time period. So 1.005 raised to the power 84 times your V0, which is $35,000. So then you get your answer. So value of investment after 7 years is $53,212.94. So there you go, whole question. So what did we do? So we just found the monthly rate first. We found the recurrence relation, then the rule, and then using that rule, we found the value after 7 years. Because it's compounded monthly given in the question, that's why we times it by 12. Okay, you can also use your CAS calculator for that. I hope you have watched the Adrolo video for the detailed information, and all the steps are in your book as well, textbook. So what do you need to do in that? So for example, if you need to use CAS, you can do this question. Karina invested $36,000 in a term deposit. Term deposit is where you deposit your money for a particular term, for years, 2 years, 5 years, things like that, and you get some interest back on your money. So Karina invested $36,000 in a term deposit, earning 8.1% per annum compounded yearly. So that's interest rate she is getting. Give answers to the nearest cent. What is the value of her investment at the end of 5 years? So end of 5 years, you need to find the future value. So FE is the future value. So if you go to your CAS calculator, to your calculator page, go to the menu and then go to the finance solver, and you will see all that there. So N is the time period. So end of 5 years, so N, you write that as 5 there. Interest rate is 8.1 yearly, you just write 8.1 here. Present value is negative 36,000 because you are giving that money, you're depositing that money into a deposit. It's going out of your pocket to the account. So that's why it's negative here. So whatever money is going out, going away from you, you always put a negative sign there. Then the payments, you're not making any payments, so it's 0. You're not getting any payments back, so that's 0. Future value you need to find out, and that's the payments per year is 1, compounded it's 1, and you're getting at the end of year. So you just put that in your CAS and go to the future value, your cursor next to it, and enter, and you will get the future value as the answer. So, and how much interest did she earn? Whatever answer you get the future value, take away your present value, that will give you the interest. So that's how you do using CAS calculator. So let me know if you need any help. I can show you that on my screen as well. It will just take some time to load, so not showing you here, but I will definitely show you one example on CAS maybe next time, or you can watch the Adrolo videos. All the instructions are in the book as well. And you need to know how to use the finance solver for your exams as well, because it will make your life easy. So for today, I want you to do just up till that part. We are not doing all of the exercise 6.5 today because it's a bit long. So you can do just the prep questions 1, 2, 3 for today. And once you're done, you can move on to doing the exam practice questions, these ones. And after that, you can, if you're done, you can do the extension questions for today. We are not doing the effective rate of interest today. If you're done with all that, you can definitely do that yourself, and I'll make another recording for that for next time and do that reflection as well, and make sure you're watching Adrolo videos as well. So write on your notes, do the questions, and just ask me questions. All right, see you next time. Bye.